There we go. All right. Um, Hello and welcome to Pre-College Math. This is week number 7. Yes, I know you guys are going to say week number 7 already. Yes, week number 7 already. It is. It goes by so fast. It's unbelievable. This week, I'm not going to say that it's easy because it's kind of tough. I mean, we're doing inequalities this week, and a lot of you would say inequality is not a big deal. However, linear inequalities, super easy. Most kids will not have a difficult time solving a linear inequality. However, if I give you a quadratic inequality, a rational inequality, those are a little bit more difficult because you can't just answer the question. You have to what do I want to say? You have to graph it out at the end to find out what the real answer is. So it does take a little bit more work to solve inequalities when they're rational and when they're quadratic. Absolute value ones take a little bit more time to solve. So what we're going to be doing today is we're going to go through this. I just want to bring up the practice because, man, I don't know what's been happening, but sometimes the problems that we go through aren't the same order that's on the practice. So I'm just trying to make sure that they are the same. So when you guys go off, you'll know what's on there. Okay, so here is the Desmos presentation for this week. There is a lot of problems that we have to go through this week that I think some of you are going to struggle with. There is no question that it is a little bit tougher. Okay, so here is the Desmos presentation, the pass key to get in. So if you guys can just jump into that and we'll get going. As I said, doing the ones that are linear are pretty easy to do. I mean, most students don't have any problems with those. So I need to, oops, I did not. Sorry about this. Sometimes coming out of my other class, I forget to jump into the Desmos presentation here. Okay, so I need to share this. Share application screen, Chrome tab. No. Okay, all right. So what we want to do is we want to go to slide number 3 right away. Okay, now this is an easy problem. It is a linear inequality. Makes it pretty easy to do. This is not one that I would think many students would struggle with. Okay, this is one that maybe some kids are going to struggle because there's a fraction in it. I don't know. I mean, when there's a fraction, usually what I would do is I don't usually leave fractions in my work. So normally I would just get rid of the fraction. So the first thing I would do is I would just multiply through by 7 every single term by 7. So if I was doing this problem, the first thing I would do is I'd look at it and I'm like, oh, I'm just going to multiply everything by 7. So I multiply this by 7, this by 7, this by 7, and this by 7. So what happens here is this goes away. I'm left with 6x minus 56 is less than or equal to 7x minus 63. That is my first step. I don't like dealing with fractions, so I would just get rid of them. Now, did I have to do that? No, I did not have to do that. I could have left it in there, but for me, not a big fan of fractions, or just go through and get rid of them. So my next step, I have variables on both sides, so my next step, I would subtract 6x from both sides. And if I subtract 6x from both sides, I'm left with negative 56, less than or equal to 1x minus 63. I'm going to add 63 to both sides. And I end up with, what is that? 7 is less than or equal to x, or it is read x is greater than or equal to 7. So this would be my answer. So it looks like my answer is letter D for this problem. Okay. Remember, when you're doing inequalities, you flip the inequality symbol if you multiply or divide by a negative number. I did not multiply or divide by a negative number, so I don't flip the inequality symbol. All right. Does that make sense for that first practice problem? Okay, are you guys okay with that? Are we good to go on, or I know a couple other students have just joined, so I'm just going to put the Desmos in there again, presentation. Okay, so are we good with that? I'm not seeing anybody say yes, so I'm hoping we are. Okay. All right, so that's practice problem number 1. Done. Practice problem number 2. Let's take a look at it. I believe it is another linear equation. This is another linear equation. However, it's a little bit different. This one is called the compound inequality. Still linear, still would solve it basically the same way. If I was going to solve this one, I'm going to go -9 is less than or equal to, and I'm going to multiply through by that -1 in front. So that would give me -3x minus 3 is less than 30. That would be my first step. Now, it's a compound inequality, and I can solve them. I just draw a line down. So if I was going to, I'm solving for x in the middle, so I'm going to add 3. But if I add 3, I have to add 3 to both sides here. So I'm left with, oh, my pen wasn't working there, -6 less than or equal to -3x, which is less than 33. Okay. Now, my next step is to divide by -3. Well, guess what? If you multiply or divide by a negative number, you must flip the inequality symbol. Well, there's 2 inequality symbols I have to flip. So this is going to be -6 divided by -3. That's 2 is greater than or equal to x. And I have to flip this one, which is greater than -11. Okay, so my answer should be x is greater than -11. X is less than or equal to 2. So if I go up here, less than or equal to, so x is less than or equal to 2, no, less than or equal to 2, x is greater than -11. Does that look right? Looks like letter C. Is that correct for that one? So that is a compound inequality. Okay, so those are fairly easy to do. Now, when we get to the next type of problem, the next problem is an absolute value problem. Ooh, absolute value. You cannot solve an absolute value inequality, but what you do is you rewrite it without an inequality symbol. So that's a 6 there. But then remember, inequality is positive or negative. So what I do is I put a +6 here and a -6 over here. There's really not much more to do in this problem. I'm done. It's already solved. So x is greater than -6. X is less than +6. So my answer is letter D. Done. That's number 3. Now, number 4, I am going to let you guys work out yourself. Okay? And it is another absolute value problem. Okay? Now, this one's a little bit tougher. Why is it a little bit tougher? Well, guess what? You've got more problem there. Before you rewrite the problem, you have to get the absolute value by itself. So what I'm going to do is I'm going to let you guys work on this one, and then we'll go through it. All right, so try to come up with an answer, and then as soon as you're done, we will go through this. So let me see here. We've got almost everybody is signed into the Desmos presentation here. Okay, if you still need to sign into the presentation, let me put that back in there. All right, so I'm going to stop talking and let you guys work on that and see what you get. All right. I didn't know it. I did not know I could do this. There were a couple people that I wrote on your slides. Do you guys see that when I write slides in Desmos? Because it looked like I could click on a slide and write, because somebody had, instead of a 17, they had a 1 there. Could you guys see, for those of you that I wrote on your slides, could you see that I wrote on your slides? I don't know if that shows up or not, but I was able to write on a slide. And I thought that was pretty cool, because then I can just correct, when I see an error, I can just write on there. And nobody's saying anything, so I'm not 100% sure that they could see it. Darn it. Okay, Samantha, I'm going to pick on you. Could you see the writing that I did on yours? Because it looked like you added 3 instead of subtracting off 3. Were you able to see that I subtracted 3 instead? No, darn it. Darn. All right, so I guess that didn't work as well as I thought it was. Okay, so let's take a look at this problem. First thing I'm going to do is I'm just going to write it over here. Absolute value of x plus 17 plus 3 is greater than 20. Now, first thing you want to do is you want to get the absolute values by themselves. So you want to isolate this. So the first thing I did is I subtracted off 3 on both sides, or on this. There's only one side. So then I end up with the absolute value of x plus 17 is greater than 17. Now that I have the absolute value symbol isolated, I'm going to write it as 2 problems. I'm going to go negative 17, 17, and then I'm going to put the absolute value inside. So now that is how I rewrite it without the absolute value symbols. Next step, I'm going to solve. So I'm just going to subtract off 17 from both sides. I'm going to subtract off 17 here, subtract off 17 here. So this gives me negative 34 is greater than x, which is greater than 0. So my answer, let's see if I can find my answer here. X is less than negative 34. X is greater than 0. That looks like letter D. If I'm looking correctly at the symbols on there. Okay. So does that make sense? That first you have to isolate the absolute value symbol, and then you're going to solve. Then you're going to rewrite it as basically 2 problems, and then you have to solve there. Okay. Does that make sense on that problem? Okay. Let's try another absolute value problem. The next absolute value problem is the next problem. It's 4 times absolute value of x plus 10 is greater than 8, okay? So we want to isolate the absolute value, so your first step is going to be to divide through by 4, okay? I am going to let you guys finish this problem up, but I will tell you that your first step has to be to divide by 4 because you want to get the absolute value by itself, okay? Finish that up. That is slide number, let's see here, that's slide number 8. And I'm just going to watch people work and see how you guys do here. I'm going to go to slide 8 first. Okay. Okay, looks like you guys are doing a wonderful job. First thing, divide through by 4. So you end up with the absolute value of x plus 10 is greater than or equal to 2. Then I'm going to rewrite this as 2, got a negative 2, got to keep the symbol the same direction. Okay, so now my next step is just to subtract 10 from everything. So subtract 10, subtract 10. So I'm left with negative 12 is greater than or equal to x, which is greater than or equal to negative 8. Whoa. Those answers don't even look, oh, I suppose they didn't divide through here. I'm looking at my answers like, what the heck is going on here? All right, so 48 divided by 4 is 12, so this would, okay, so x is less than or equal to negative 48 over 4. That looks good right there. X is greater than or equal to 8. Well, 32 divided by 8, that looks good right there. I am going to go with letter E for that answer on that one. I don't know why they left them as fractions. That's kind of weird why they would do that. But I would go with letter E. Does that make sense? Does E? Okay, I see a couple of people had letter C and D. Is E now? And this is sometimes it's hard, because I always read it. What is the difference between C and E? All right, C, we have x is less than or equal to negative 12. That's correct. X, oh, they look exactly the same. Letter C and E are exactly the same. Whoa, that shouldn't happen. But let's see here. I'm trying to see if there's a difference there, but they look exactly the same. Huh. I will tell you that the answer on my answer sheet is E. I could not disagree with letter C, because letter C is the exact same thing as letter E, but on my answer it is E. So please put E down in the practice, okay? But Wesley, you're absolutely correct. They are exactly the same. There is no difference at all between those two. I'm gonna have to make a note of that. I'm gonna have to change one of those answers. Most likely C. I'm gonna have to put a plus sign in there someplace. All right. Now, those are fairly easy. We did linear, we did absolute. Now we're gonna go into irrationals, okay? Now, a rational inequality is a little bit tougher to solve, okay? And I'm gonna go through this one with you guys. When you do a rational and a quadratic, we're going to be talking about quadratics in just a bit, but when you do a rational one, you have to find the points that solve it and where it makes it not equal to 0. For example, I look at this problem, x plus 27 over x plus 3 is less than 7. Is there any answer that makes undefined? Well, sure, negative 3. When x equals negative 3, this is undefined. So I have to put that off to the side. So that's a point that I have to check out. And then I'm going to solve this. I'm going to cross multiply. So I'm just going to, this is really 7 over 1, right? So I end up with x plus 27 is less than, and then x plus 3. So I'm going to end up with 7 times x plus 3. And I'm going to solve this. So that's x plus 27 is less than 7x plus 21. I'm going to subtract an x from both sides. So I end up with 27 is then 6x plus 21. I'm going to subtract 21 from both sides. And I end up with what? That's just a regular 6 is equal to 6x. So x is greater than 1. So now I have two values that I have to check out. And some people would say, what do you mean you have to check out? Well, I'm going to put it over here. X equals -3. X, I can just put 1 here. That doesn't matter. So what is, you make a number line. You put your two values on here, -3 and 1. Okay. Then what you do is you check to see where it's true, and that is where it should be shaded in. For example, if I take a point over here, -4. So if I put that into this original equation, if I put -4 in here, -4 in fractions, so that gives me, what is 23 over -1? -20, so that's -23 is less than 7. Is that true? No, sure it is. -23 is definitely less than 7. So that means this is shaded in. Usually if you have one side shaded in, the other side is going to be shaded in. Okay. Now, I could try it. I could put, let's just number 2. That would be in this area here. So if I put 2 in here, that would give me 29 over 5 is less than 7. Is 29 over 5 less than 7? Sure. It's like 5.9, something like that. So that is true. So my answer is everything less than -3 and everything greater than 1. So how do I say that in here? Let's see here. -infinity to -3, yes. 1 to 8. Or I'm sorry, 1 to 8. 1 to infinity. That is also yes. So I would say that my answer is letter B. That little union there means it includes both of them. It includes this set and this set. Okay, so my answer to, what number is this? Number 6 would be letter B. Okay, so that is how you do a rational equation. You have to find out if there's anything that makes the denominator equal to 0. You have to check that out. You got to put it on your graph. Okay, so now when we get into quadratics, we have to do exactly the same thing. We have to check out endpoints. Okay, now in this problem, I don't have to, in this problem, if you are really smart, there's no work to be done on this problem. And somebody's going to say, but Mr. Shanklin, we are really smart. Yeah. But look at the endpoints. Remember, if you have square brackets, you know it's either less than or equal to or greater than or equal to. And if you have rounded brackets, it's less than or greater than. Well, I know that this is a less than symbol, so that can't be a correct answer, because that would be, you can't have square brackets. I have a square bracket here, a round bracket. That can't be my answer. I have a square bracket, round bracket. That can't be my right answer. This one can't be my right answer. It has to be this one. Okay, now how do I do it algebraically? Okay, anytime you have a quadratic, you have to do exactly the same thing as we did with the rational. First thing you have to do is you have to solve it. So x squared, I'm sorry, that was just this. So I just solve it like normal. So x is equal to plus or minus 2. So we make a number line, plus or minus 2. So I take 2 here. Sorry, I take -2 here. I take 2 here. I'm going to try the value 0. I'm going to plug 0 in here, see if it makes it true. So x squared is less than 4. That was my original equation. So if I put 0 in here, 0 squared is 0. That's less than 4. That is a true statement. That means wherever 0 is, that has to be shaded in. That is shaded in. That is my solution set. Everything between -2 and 2 is a solution to this problem. Everything on the outside is not a solution to the problem. Okay, so now we are going to give, so what is my answer? Letter D there. Okay, I'm just going through making sure my practice matches up with everything that we're doing. So now I'm going to let you guys do a problem. I want you to go to slide 11. Is there any problems that we could cross off, or any answers? Okay, that's my first question. When I look at this problem, is there anything I can cross off as an answer that doesn't make sense? That it's like, I know it can't be this, and I think there's probably 2 of them that we could cross off. Okay, what 2 answers can I cross off that I know cannot be my answer? D cannot be an answer. E cannot be an answer, right? D and E cannot be answers because we know from the endpoints. So right away, I just cross off D and E. I know they're not. I know they can't be right. Oops. So I'm crossing them off. All right, so I know it has to be A, B, or C. So now and they all look basically the same, don't they? I mean, look at the answers. It's like, wow, they're pretty close. So I'm going to let you guys work and see what you guys get for an answer. All right, so I'm going to turn off my mic. I'm going to let you work. Now, this is a much harder problem, but remember, you could really solve this problem this way. You can go x minus 7 squared is equal to 1, because what you're really doing is you're trying to find the two values, and then you're going to plot them on the graph, and then you're going to see if they work. So I'm going to stop talking, which is very hard for me to do. I'm going to let you guys work. Wesley, x minus 7 squared is not x squared plus 49. That is not a true statement. Get that out of there. All right. Now, Wesley, you did it exactly the same way that I was thinking of doing it. And then I looked at, let's see here. Is it Arnish? I don't know if I'm pronouncing that right. And Samantha, I'm looking at their work and it's like, oh man, why am I doing it that way? So Wesley, what Wesley was doing is he was multiplying this out, and that's exactly the way I was going to start. I was going to just say, okay, well, that's, oops, I got to get my pen to work here. That would be x squared minus 14x plus 49 is equal to 1. Bring that 1 over because I want to set it equal to 0. So x squared minus 14x plus 48 is equal to 0. Then I would have factored this. I would have said 8 and 6. So I'd get x minus 8, x minus 6 is equal to 0. And then I'd say, okay, my solutions are x equals 8, x equals 6. So then I would draw my number line out here. I would put 6 here, 8 here, and then I would take values. I always take 0 because 0 is way over here. I always take 0. Why do I take 0? Because 0 is easy to plug in, okay? That's the only reason I take 0. And I've learned from many years of doing this that if it's shaded on the outside, it's going to be on the outside of both. And if it's not shaded on the outside, it has to be on the inside. So I take and I put 0 in here. So I put 0. 0 minus 7. 0 minus 7 is negative 7 squared is equal to, or I'm sorry, I have to put my symbol in there again. So negative 7 squared is 49. Is 49 greater than or equal to 1? Absolutely is. So I know that 0 has to be shaded in. So I know that this has to be shaded, and I know this has to be shaded. I know that that it's greater than or equal to, so I know it's a square bracket, square bracket. So I know that my answer is going to be positive 6 and positive 8 going in both directions. So it looks like B is the correct answer there. Okay? Do you guys agree that B should be the correct answer? Now that is one way of doing this. And Wesley, that is exactly the same way I thought about doing it. But then I looked at other students' methods and it's like, why am I doing all this work? So let me erase this. Then the others in the class did it a little bit easier. They took the square root right away. Oh, that kind of makes sense. So then they ended up with x minus 7 is greater than or equal to plus 1 and x minus 7 minus 1, right? Because you end up with plus or minus. So if I add 7 here, I get x is greater than or equal to 8. And if I add 7 here, I get, well, I shouldn't have used the inequality symbol. I'm just looking for my values is all I'm doing, and that would give me 6. You can't keep the inequality symbol in there. So then again, I go back to drawing it out. I have 6 here, I have 8 here. I would have taken 0 again. So this was a little bit easier to do. I just passed me by when I was doing that until I looked at some students working, and it's like, oh, that would have been much easier. Now, Wesley, the way you did it worked out just fine. Okay, so there's more than one way of getting the answers to these problems, but I believe our answer to this problem should be letter B. All right, so here's another one that is very similar. Is there any answers that I could cross off right away? Okay, so that's where I always start. I always start with, is there anything I can cross off that I know it can't be that answer? Letter E, I agree. I think there's one more that we could cross off. Letter E is definitely going to be crossed off. And letter B, right. B and E, I can get rid of those. I know it can't be these two, so I can just cross them off. So those are gone, B and E. Now, in this problem, I'm just going to rewrite it as x squared plus x minus 6 is equal to 0. Okay, why do I put the 0 or equal sign? Because it's an inequality. It doesn't really matter what the inequality is until the very end. So I'm going to factor. I'm going to factor this thing down to x plus 3, x minus 2. I think that's right. Yep. Is equal to 0. So x equals negative 3 or x equals 2. Now I put my number line down. I've got negative 3 here. I've got 2 here. Then I go back to the original equation. X squared plus x is less than 6. Pick a point. I always pick 0. I'm sorry, but it's the easiest point to pick. So I put 0 in here, 0 plus 0. So 0 is less than 6. Is that a true statement? Sure is. 0 is definitely less than 6. So I know 0 has to be shaded in. So I know my answer has to be between negative 3 and 2. Has to be. So now it's a less than symbol, so it really better be the rounded brackets, right? So this is what my answer should look like. It should be everything between negative 3 and 2. So it looks like negative 3 and 2 looks like A. Is that correct? Looks like it should be A. Okay. Any questions on solving quadratic inequalities? You solve it just like it's a regular equation or quadratic equation, but then you have to plot your points out to see where your solutions end up. Okay, that's the only difference when you're finished, is you have to figure out what your solution set is. All right, I think we only have one more problem on the practice. Okay, and I'm going to let you guys do this one yourselves. Okay, so this is slide number 13. Okay, is there any answers that I can cross off? Because that's where I always start. I always want to start to see if I can cross anything off. Anything that we can cross off on the last practice problem? Okay, anything that we can cross off? Letter B. I'm not going with B. D and E. D and E. Yep, D can be crossed off. E can be crossed off. I think those are the only two because I think everything else is a rounded bracket. Oh, D, okay. D and E. I'm going to go with D and E. You guys are right. Yep. D and E can be crossed off, but I'm gonna be quiet now. I'm gonna let you guys work and see if you guys can get this answer because this is a big portion of today's this week's assessment. Samantha, I would, since it's a quadratic, I would get it set equal to 0 and then factor. Because dividing through by 2 is going to cause you some headaches because you'd end up with x squared over 2, which is really going to cause some problems. All right. In this problem, if I was going to do this problem, the first thing I did is inequality means nothing, okay, until the very end. So I'm just going to rewrite this and set it equal to 0. So I've got x squared minus 2x minus 24 is equal to 0, okay? I'm going to factor it. Most of them are going to factor. You're not going to have to use quadratic formula because that would really be a pain. Let's see here, 6 and 4, so x minus 6x plus 4. So my two solutions are going to be positive 6 and negative 4. Make my number line. So I'm going to put negative 4 here. I'm going to put 6 here. 0 is always the easiest value to use. So I always use it. So I'm going to put 0 back in here. So 0 squared is 0. 0 is greater than, if I put 0 in here, that's 0 plus 24. Is 0 greater than 24? No way. That is, 0 is not greater than 24. So that means I know this isn't going to be shaded in between -4 and 6. So I know that on the outside is going to be shaded in. That is what that tells me. So I know that between -infinity to -4, that's going to be shaded in. And I also know that between 6 and positive infinity is going to be shaded in. So I look up here, and it looks like letter A would be the correct answer. So when you're dealing with a quadratic inequality, it's exactly like solving a quadratic equation. It's just that at the end, you have to plug the values back in. Okay, does that make sense? I mean, there's only one extra step. You just have to plug it in to see where the shaded region is going to be. That's it. Okay, now on this week's assessment, guess what? I made it pretty clear what I want students to know. The first problem on the assessment is going to be, do you know how to solve a linear inequality? Second problem, one second, I have to sneeze. I better turn off my mic. 1 second. Oh, sorry about that. The second type of problem that you're going to have to know is how to solve an absolute value. And the third type that you will have to know how to do is a quadratic inequality. So everything that's on the assessment this week is going to be inequalities. The only problem is they're going to get progressively harder. First, you're going to have a linear inequality, absolute inequality, quadratic inequality. So let's go through these. First one, if I have 7 is less than, and this is going to be -1, negative k minus 3 plus 2. I'm going to multiply through by -1 here. So I've got 7 is less than k plus 3 plus 2. So 7 is less than k plus 5. Subtract off 5. And I end up with 2 is less than k, or red, k is greater than 2. So if I was going to graph this out, +2, that should be an open dot, and everything graded, shaded to the right of that. All right. Any questions on the basic type of questions for this week on the assessment? Okay, those are just going to be linear inequalities. Remember, when you're solving a linear inequality, if you have to multiply or divide by a negative number, you must flip the inequality symbol around. Okay. So are we good with linear inequalities on the assessment this week? You guys all right with that? Then the next type of problem is going to be absolute value problems. Okay, so how do we do absolute value? Remember, first we have to isolate the absolute value symbol. So I would divide by 3 here. So I end up with the absolute value of 4 minus 5x is less than or equal to 3. Now I'm going to rewrite it as 2 separate problems, -3, and always make sure you keep the same symbol in there. And then 4 minus 5x. So now this is what is called a compound inequality. So I'm going to solve. First thing I'm going to do is I'm going to subtract 4 from both sides. So -7 is less than or equal to -5x, which is less than or equal to -1. This is where now my next step is to divide through by -5, but when I do that, I have to flip the inequality symbol. So this is going to be 7/5 is greater than or equal to x, and then I'm going to flip this one. So this is going to be greater than or equal to 1/5. So solving absolute value problems, just have to remember to rewrite it as 2 separate problems. Okay. Any questions on the first 2 types of problems that will be on the assessment this week? You guys okay with all of this? Because this is your time. I always want to make sure that I give students time to ask questions. We went through all of the problems on the assessment this week. There's some tough problems on there. And then what's going to be on the assessment. And then the last type of problem that will be on the assessment this week will be quadratics. when you solve a quadratic, you don't have to even look at the inequality symbol. I always just put an equal sign in there. But in order to solve, remember, it has to be set equal to 0. So I'm going to subtract off 9. So I end up with x squared plus 4x minus 5 is equal to 0. And if I do this, I get x plus 5, x minus 1 is equal to 0. So my two values are negative 5 and x equals 1. Make my graph out. So I have negative 5 here. I have 1. I always choose 0 because 0 is the easiest thing to put in. So this would be 0 plus 4 is greater than or equal to, that was a positive 9 here, right? Positive 9. Is that a true or false statement? 4 is greater than or equal to 9. That is definitely a false statement. That is false. So that means 0 is not shaded in. So that means I have to shade on the outside. And that would be solving a quadratic inequality. All right. Whew. That was a lot of work. No question about it. Any questions on any of the stuff that we've gone through this week? You guys have about 15 more minutes that you can ask any questions that you have about any of the material that we've covered this week or anything that we covered last week or the week before that. Any questions on anything? And if not, that was it for today. Hopefully we'll see you back next week, same time. All right, see you, Wesley. And anybody else that wants to stick around, we can go through any type of problems that you'd like.